we are going to read about volcanoes. Now, are we going to get this through this whole book in like one reading time? Probably not. So we're going to get this going, and we'll probably have to finish it tomorrow. What kind of book do you think this is? Thank you for raising your hand, Elizabeth. Okay, it is about volcanoes. What I mean by, do you think that it is a fiction book or a non-fiction book? Who remembers what those are? We've talked about them a few times. What do you think, Anaya?
It's a fiction book because volcanoes are real.
Okay. You're right on part of that. Who can help Anaya where she made her goofy mistake? Jimmy?
Non-fiction.
Non-fiction. So she's totally right. Volcanoes are real. And so it is a non-fiction book because fiction means that it is made up, make-believe. Non-fiction means it is not made up, not make-believe. Okay? It gives you real information.
Lava and volcanoes.
Jimmy, I am so glad you're excited about it, but I do need you to be respectful of others and let me read and let me call on other people. Okay? Thank you. But I'm super excited that you're excited. Okay. Volcanoes. Open your eyes to a world of discovery. Volcanoes. It's a fun lava erupting picture right there. Ooh. Okay, and then this is called does anybody remember when we get to this page, what is it called? Danny? Why do you have your hand in the air? What?
I was thinking my arm.
You don't stretch your arm like this. Nice try. But do you know what it's called? No? Okay, who can help her out? I've got a few second graders. Ooh, eeny, meeny, miny, Amy.
Table of contents.
Excellent. Pat yourself on the back if you remembered that. If you did not remember that, store that information in your brain. So, Danny, it is called the table of contents. What's it called, Danny? Of course, I asked her. Table of contents. Very good. What does it help you do? What does the table of contents help you do? What is its purpose? Hayden?
It helps you find pages if you want to read that part.
Right, it does. It helps you find specific information, or like if we close this book and we said, oh wait, where was I? I forgot to put a marker in there, but I realized I just read about in hot water, so I'd know what page to go to. But yeah, if you were doing a research project, kind of like second or first graders did yesterday, where you read a book and then you wrote a little bit about what you read, right? If you were writing a book about volcanoes and you needed to, or writing an essay or a little, paper about volcanoes and you needed to learn more about them, and you specifically wanted to know about working or working near a volcano or visiting volcanoes, you would know where to go to. Okay, so table of contents can be very useful. Luis, did you have anything to add? So you remember about reading about volcanoes in another story earlier last week. Yes, you read about Alaska, and I believe you guys are second graders. You guys will be reading more specifically about volcanoes and other changes to land this week. So it'll be kind of fun to learn all this information. So spitting fire deep under the earth, rocks melt into a thick liquid called magma. And second graders, I will hop back there so you can see the picture, okay? When the pressure in the Earth's crust builds up, the magma explodes into a volcanic eruption. And then right here, there are actually a lot of captions. Captions are just little information about the pictures and stuff that gives us additional information, okay? Hot heat and fire. The red hot molten rock that explodes out of a volcano is beautiful, but deadly. It is so hot that it can melt steel. Do you guys remember what steel is? What is it? Jaya? Yeah, it's a kind of metal. Very good. Earth's crust, and then right there it kind of shows in the picture that the Earth's crust is made of layers. So we can see the Earth's crust is made of loose rocks and dirt, sedimentary rock made from bits of rock stuck together, and then igneous rock that made from magma that has cooled, metamorphic rock made from squashed rocks. So there's layers in the Earth's crust. Okay, and they call that because, that's what, like the crust of a pie, it's on the outside. Okay, if we had a picture of the Earth here, whoa, that marker doesn't work.
I barely even see it.
Yeah. Okay, and the crust is actually not that deep, but we're just going to say, ooh, here's the crust. And there's many layers of the crust. And then I think we'll maybe talk about other layers. And if we don't, we'll look it up and get that information. So here's the crust. Well, here's the Earth. And then this is the crust layer. And then I believe, and then we'll go into magma and everything like that. But okay. Once it is risen to the surface, magma is called lava. So when magma is under the crust, it is called magma. When it comes to the surface, it is called lava. Very good. As it rises, the magma breaks up rocks near the surface, which can cause earthquakes. Ready to blow. The force of an exploding volcano can throw lava more than 2,000 feet or 610 meters into the air. 2,000 feet. Right? The Kennison is only 5 feet tall. Okay, for comparison, 2,000 feet. I don't even know what to compare that to, Mr. Squatrito. 2,000 feet.
Maybe two other volcanoes.
Probably.
So like 2 times as tall as Cactus Peaks, or maybe, or I was wondering from like one end of 93 to the other, like in town. Maybe that's, I don't know.
You said 2,000 feet?
2,000 feet.
Actually, it might be as tall as that.
Oh, maybe just as tall.
I was thinking.
Yeah, no. So that might be as tall as Cactus Peaks. That's not.
What about this good 5,000? I don't know.
I would hope that we live in Jackpot, which is a pretty small place. You better all know Cactus Peaks. All right, okay, boys and girls, please put a bubble in your mouth. I am coming, please don't fuss at me about pictures, I'm coming over. Okay, can throw lava more than 2,000 feet into the air. Lava, gas, and huge chunks of rock are all ejected from a volcano. And I am, how on earth did that happen? Please put your body back in your seat, honey. Oh, look. I've got more layers here. Oh, fun. Okay, cool. The Earth's crust is a layer of rock between 3.5 and 42 miles thick. The layer of moving rock below the crust is the mantle. And there's the lower mantle, outer core, and inner core. Peeling away the layers, the Earth is made of many layers, just like an onion. Instead of onion skin, the Earth's layers are made of rock and metal. Deep in the Earth, below the mantle, is the outer core. This layer is made up of iron and nickel that is melted. Below this is the inner core where the temperature reaches 8,130 degrees Fahrenheit. I can't even fathom how hot that is, but it is very, very, very hot. So let's add to our picture. So we've got the crust. Thank you, those of you who are being quiet and respectful. If you are talking to your neighbors, you are not being respectful for their ability to learn, right? So the crust followed by the lower mantle, followed by the, oh no, sorry. First it's just the mantle. I was confused on that myself. And then lower mantle. And then we have the outer core. And then the inner core, which is the really, 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 really hot part. Really, 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 really hot part.
Wow.
Yeah. And obviously, we live out here on the crust. We don't get into that hot part.
Someone tried to.
Jigsaw Earth. The Earth's crust is broken into pieces called plates, which are always moving. Sometimes we can feel the movement as an earthquake. Many volcanoes occur in a place where plates bump together or pull apart. Okay, and then when we're looking at this map here, it's got a key, and it's got, a little triangle with like smoke coming out of it. It shows a volcano. Blue is sea or water, because it's the Great 8 lakes in there are blue, so obviously that's not sea. Green is land, and then the red is magma. Okay, and the magma is kind of, around these plates, the edges of these plates that make up the earth. And those plates tend to move, and then that's where we get earthquakes and also volcanoes, is when those plates move. Visible fault. The San Andreas Fault in California is a place where two plates slide against each other. The plate moves about ½ an inch or 1 centimeter a year. And you could tell that the plates are there because of like these mountains and hills that have been created. It just forms a perfect line around where the plates are. All in a row on Lanzarote, Canary Islands, magma bubbles up in places where plates break apart. These weak spots are called fissures. And you could see it all right in a row there where the magma has come through along that plate in these bubbles, and pretty cool. Okay, so the crust is kind of broken up into these plates that move, but you obviously can't see them very much, but you can kind of see where they've been moving together, because that's where they cause a lot of mountains. And the volcanoes, which are, show up as mountains, appear right along those edges. Cool. The more you know. And the ring of fire circles the Pacific. And it's called the ring of fire because along this plate there's a ton of volcanoes. So they call it the ring of fire. The plates glide on layers of hot, flexible rock. Ah, Troy, would you like to sit up and see? Well, a lot of books have the same information, but you can get additional information or help your understanding by continuing to listen instead of just saying, I read books on volcanoes, so I don't need to listen to them. Okay. Hotspots. In some places, the Earth's crust is thin enough for a column of hot magma to burn a hole and create a volcano. These places are called hotspots. What? I will get to you, don't worry. Hot water spot. Yellowstone Park in Wyoming is located over a hot spot. 2 million years ago, a volcano erupted there. Today, underground heat fuels the park 10,000 geysers. Who's been to Yellowstone? It's a national park. Pretty close to us, actually. Hot spots. Those are hot spots. So where volcanoes are like So Yellowstone, if you've been there, you've seen like the geysers, the water shooting up into the air, and you've also seen a lot of just like hot springs where the water is just sitting there, and you could tell it's hot because steam is coming off of it. And if you walk on some of the paths near it, you start feeling hot. Like, whew, it's a bit toasty over here. Okay, and that's because the crust is thin there, and the magma is close to the surface. And so it is hot enough to warm up the water and stuff there. Lava erupts from Kennison-Squatrito in many places at the same time. Island of Fire, Reunion Island in the Indian Ocean, contains one of the world's most active volcanoes, Kennison-Squatrito. Reunion Island formed over a hotspot about 5 million years ago. So they can watch all these volcanoes going off at the same time. Formed over a hotspot. Watch. That's like the whole Earth flattened out. And then these are the yellow parts of the plate lines. So those are the plates. Yeah, so we're up here in North America, and Yellowstone is right there on hotspot, which is right there close to where we are. We are in North America. We are in North America, but Yellowstone is back here. You could get there one day. You probably, I can only take what, about 4 hours, Mr. Squatrito, to Yellowstone? 5.5 hours to get to Yellowstone from here. But by the time you get there, it would be late and you couldn't do anything. So you could go this, on spring break or this summer. It'd be pretty cool. Pretty cool to see. Highly recommend. Okay, in the ocean, the thin plates at the bottom of the sea are most easily pierced by hot magma. When this happens, an island is formed over a hot spot. So did you know many islands are created through volcanoes? Whoa. Who's seen Moana? You've seen Moana?
I watched them.
Yeah. So, when Tahiti, isn't that it? When she loses her heart, right? And then she turns into this lava creature. Some of that is based in truth because there are volcanoes that go off in the Hawaiian Islands pretty frequently. And that is how the islands were actually created is because of volcanoes, volcanic activity. Pretty cool. Underground oven. The Azores Islands lie over a hotspot in the Atlantic Ocean. People here take advantage of the free underground heat and use it to cook their food. This pot contains dinner for an Azores family. Whoa, that's pretty cool. So they dug into the earth where the crust is pretty thin. It's a thin layer, so it's close to, in the hot spot, the magma has risen up, and so they can actually use that heat to cook their food with. Can you guys imagine cooking food just by sticking it in the ground and not having to add a fire or anything? Because people here will sometimes cook food in the ground, but what they'll do is they'll create this big pit and then they'll set a fire in the bottom of the pit, get a nice hot bed of coals and stuff in there, and then put their food in there, and then they'll cover the top of it. You don't even have to do that there. You can just stick your food straight into the ground. I know. Crazy. Crazy. All right, and then this is probably the last section that we'll get to read today, and we'll continue this tomorrow.
Whoa, I like that stream of lava.
It's pretty cool.
Yeah.
Red hot rivers. When a volcano erupts, hot liquid rock either explodes outwards or flows onto the ground. Once it is outside of the volcano, the liquid rock can cause a lot of damage. Destructive heat. Hot liquid lava spreads out into rivers that cover the countryside before it cools. It burns anything in its path, even roads. And when I walk around, you guys have to look at this picture. Jimmy, careful, bud. You need to put your mask on. You're finish up with breakfast. Get that mask on your face. Don't be coughing at me. All right. It can even set roads on fire. Exploding out. Sometimes the liquid is under a lot of pressure underground. When this happens, the lava spurts out or explodes out of the volcano. I don't know how to say this. And Pohoho. There are many types of lava. Lava moves quickly and hardens to form sharp chunks. Pohoho lava moves slowly and often forms smooth rocks when it hardens. So it looks smooth. Pohoho lava forms and grows a smooth skin. Rock is covered in sharp chunks and is difficult to walk over once it's cooled. Slow but steady. When lava seeps out of the ground, instead of exploding, it travels very slowly. Flowing lava is easier to run away from than exploding lava, but it's just as destructive to the landscape, right? So just because it's not coming out quickly doesn't mean that, that it'll cause any less damage. As lava cools, it forms a hard skin over the liquid flow. Lava facts. The temperature of some lava is 7 to 12 times hotter than boiling water. The word I don't know how to say that. I'm going to have to look it up. And Pohoho come from the Hawaiian language. Lava can form many different shapes, such as cone tubes and even hair. It even looks like hair. And if you guys go, Craters of the Moon National Park is actually just a little ways north of Twin Falls. What do you think, maybe 2 hours from here? Or not even, an hour and a half to get to Craters of the Moon? Maybe an hour and a half or 2 hours. You guys can go to Craters of the Moon and you can see different lava, different way, like different lava, like how it hardens in different ways and different lava construction. It's really cool. And they call it Craters of the Moon because it looks kind of like what you imagine the moon to look like when you've seen pictures of the moon. It's just kind of gray and it's got the craters and stuff in there, and it looks really cool when you go there, and you can learn all about lava and volcanoes. It's pretty neat. I highly recommend it. But maybe we can take some type of virtual tour. I'll have to see if I can find some virtual tour of Craters of the Moon, and we could do that this week too. That would be really fun.
Like at school?
Virtual means we would do it like on the computer, on the smart board. And we could visit there. And then if you guys got your parents excited about it too, you could do a real visit, but we could at least like do a virtual visit, a virtual field trip. Glowing river. This intensely hot lava, I don't know, I need to figure out. It's spelled AA, so I don't know how to say that. Lava glows brightly. As it cools, the flow slows down and thickens. But since it cools very slowly, it can cover hundreds of miles before it stops. So that's kind of like, a flow, even if it's going slowly, it could go all the way from Elko to Jackpot. From Jackpot to Elko, right? Hundreds of miles. It could go from Boise to Jackpot even. Okay, hundreds
What
of miles.
about Ogden to England?
What?
England.
England? You would have to, that's a lot more than just a 200 miles here. That's a lot more in there.
Okay.
That is the slow moving lava. And
Wait.
that's the lava burning the
Wait,
road.
can I
and
go
it's
to
slowly
check what
lava.
you pop?
That's the Volcano lava that's smooth and it forms this kind of ripples and it hardens. This is the slow moving lava. And then the AA or A, that's the fast lava and it moves quickly and hardens to form these sharp chunks and it's kind of lava. All right, so we will continue this tomorrow. I'm excited to learn more about lava with you. We'll continue this. We will take a little bit of time to do some, it is the St. Patrick's Day tomorrow. Don't forget to wear green. Don't forget to wear green for luck. Okay? All right.
Kennison.